Hi everyone, my name is Aniket Devecha and I'm the Assistant Sales Manager for Analytics. Thank you very much for everyone for taking your time to join us on our webinar today. The webinar is recorded and in today's webinar, we will discuss the Agilent 990 Micro GC technology along with its benefits for the solution. I'll be your host for today and I'll now hand over to our Director, Duncan Rowe, to start today's webinar. Thank you.
Okay, thanks Aniket for that and welcome to everybody online. Thank you for joining us today. So as Aniket mentioned, the purpose of this webinar is going to be to have a look at the Agilent 990 Micro GC. So the topics we'll cover is really how we define or what a Micro GC is, how the system operates, what it can do for you, and really how it can meet the rapid gas analysis needs for whether it's your lab, in the field, or as part of your process. In terms of what defines a Micro GC, I think the easiest way to describe it is that it's very small and compact. So compared to traditional benchtop GCs, the system is built off of MEMS technology. So everything inside has been micro-machined to make it smaller. What this does is to enable us to have very small footprints in terms of size. So a typical Micro GC would be almost the size of a shoebox turned on its side. So 30 centimeters depth, 30 centimeters in height, and 15 centimeters wide. So very, very small. But it's also very small in terms of its environmental footprint. So compared to conventional benchtop GCs, we are using approximately 10% of the carrier gas that you typically would, and also much less than 50% power usage, mainly due to the size of the ovens and what we need to power the system with. So as the name anticipates, Micro GC means it is a very, very small GC. What also makes its definition or to stand out really from other technologies is its speed. So when we talk about speed, the analysis time here of gas samples is typically 1 to 2 minutes, so it's incredibly fast. Now, the reason why it's very fast is because it is a dedicated platform for gas samples. We're not trying to replicate a benchtop GC where you can connect lots of different accessories and do lots of other sample introduction. We are primarily solely focused on gas samples. So with that in mind, we're able to work isothermally. So we can get to a certain temperature and keep our method there, stay at that temperature so that we can just do run after run after run. So we don't have the heat up and cool down times that people normally associate with GCs. We essentially just stay at temperature and then we can run and run and run. Also, due to the fact that we're using much smaller components in here and smaller columns, which I'll come to later, we are not taking as much sample, we don't need as much time inside the GC, and everything is much smaller in terms of the path. So speed is a really, really important factor of what a Micro GC can offer to a laboratory. As I mentioned, it is dedicated for gas analysis. So this was designed with gas only in mind. It's not designed to compete or be compared to benchtops. It really is its own sort of standing, dedicated for gas analysis. The only exceptions that we mention really are LPG and LNG, because we do have accessories that can work with these sorts of samples, but 99% of the time we're just interested in having gas to run through the platform. The system itself is very flexible as well. As we mentioned, it can be used as a laboratory instrument, so it can sit on a bench with the software package that it can run. You can integrate peaks, you can do anything you would with other analytical equipment, but it is also, due to its size, able to be portable. So we can take it out of the lab. We'll have a little look at the mobile options later, but also it can be used as a process tool, so an online at-line analyzer as well. It's an incredibly flexible bit of equipment. And also there are different combinations that we can do, which we're going to have a little look into, where essentially we can build channels from into the system. So anywhere between 1 and 4 and any combination of these channels that we wish. Now, the channel is really the core component of the micro GC. So it's made up of 4 areas. So the first one is the electronic gas control. So this part controls the flow of the carrier gas. So the carrier gas will come into the system, into this pump, and then this will control what is going to be going through effectively that GC channel. So we have options for what we call straight channels or backflush channels. Straight just means that the gas is coming in, going straight out. We don't have any way of getting rid of any portions of it. A backflush allows us to really control what we are sending to the analytical part of this channel. So if we were wanting to get rid of certain compounds that we didn't want to see, for instance, CO2 on a molecular sieve channel, we can get rid of that CO2 before. So that's what the gas control unit will do. We can also make runs shorter by getting rid of compounds that we're not interested after a certain elution time. So essentially, gas control allows the carrier gas in, controls the flow of that. And then we have the module inside this channel, which is made up of these 3 further components. So the first one is the MEMS-based injector. So this injector is what takes the actual sample. So the sample will fill this loop, which is 200 nanoliters. So it's really, really small injector. And we can control the temperature of which we want the sample to be injected into the analytical column at. So in here, we can control temperature, we can control the pressure, and we can control an injection time. So the way the micro GC operates in terms of taking a sample is not by volume, it's by time. So typically people are used to injecting 1, 2, 10, 20 mils of sample. In here, all we're trying to do is take a proportion out of that injector and put that through the analytical column. We do it by time because we're working on such a small scale, and it's much more accurate in terms of the capture of that particular sample. Once we've got that sample, it'll then pass through the analytical column. We'll take a look at the different options of these later on, but they're similar to what people would operate with benchtops. We've got plots, bulk-op, micropacked, lots of different types of columns based on the application need. And again, these can either be straight or they can have a pre-column on them, which will allow us to backflush the compounds. Then we have the TCD. So this is where we are getting the result and the analysis. So TCD stands for thermal conductivity detector. And this is what's taking the signal and providing the analysis for us. Now, it's very, very small size of a postage stamp. Very, very accurate. We can typically work with most LODs down to about 2 ppm, all the way up to 100% with gas samples. We have a really, really wide working range with this and a really, really robust technology. Now, the systems, if the 990 is new to people, the predecessor to this module was the 490 from Agilent, and the channel, as it's the heart of the system, was the part really that if you ever wanted to change application need or you had a fault with the part, you had to replace a full channel. When the 990 was developed a couple of years ago, this was made sort of in mind of having the ability to interchange the components that are within this module itself. So as I mentioned, in the module, you have the injector, the TCD, and the column. These have all now been made with smart connections in there, so we can interchange these individual parts. So if an injector went, or whether the detector went, or whether the column went, we now don't have to replace the full module. We can actually just replace the individual parts. And all of them now have diagnostic tools built into the software that will flag up any errors to allow us really to find out any root cause of what's going on with an issue. So from a point of view of ownership, it brings the cost of ownership down dramatically, because if you just want to change the column or need to change the column, you can just change that component. And we have a much greater understanding and ability to rectify any issues. So it's been a big change to the way that the 990 micro GC platform operates, is to have the ability here to change these channels, whether it's planned or unplanned. So in terms of the theory of operation, as I mentioned, the carrier gas will come into the electronic gas control module. So that's going to bring the carrier gas in. It's going to set the pressure that we need it to and the flow that we need it to. And then that is going to pass through the sample path where there's an injector die. Part of it will go through a reference column, and then that will go to the TCD. And then part of it will go through the analytical column to the TCD as well. So there's different ports on the TCD to accept these signals. What we do in terms of introducing the sample is to bring that straight into the sample injector, and we basically will mix it with the carrier gas on that analytical column path that we see, so that we have a known carrier gas coming through to a TCD, and then we have the analytical column that contains the known carrier gas, but it's also mixed with the sample. And then basically what we are going to do is check for any differences in thermal conductivity. So when we're configuring systems, the way we have to operate is to try and, if we're analyzing something, let's say of nitrogen, as a thermal conductivity of 0.0243, we don't want to use a carrier gas that would have a similar thermal conductivity. So something like argon, which is 0.0162, we wouldn't want to use that because we wouldn't see a big enough difference between the analytical column and the reference column. So what we try and do is to use something that's far ranging from that. So something like helium, for example. So if we've got a helium stream coming through as a carrier gas, we know that we've got a good disparity between that and the gases or the compounds we're trying to measure on the analytical column. In terms of the hardware, we have two options really. So you can have a GC chassis that can contain two channels. So essentially the channel can fit in the top component, channel 1, and channel 2 underneath. It can just be run as a single channel system if needed. Then if we want to, or need to, for application point of view, have a third or a fourth channel, we can connect up a second chassis that will contain these, and there will be a heated bridge in between that will split the sample from the introduction port. So if we look at the back of the system, we've got options here for putting carrier gas into each individual channel. So channel 1 could have its own carrier gas, channel 2 its own, 3 and 4, etc. Or you can just run one carrier gas to fill 1, 2, 3, 4 channels. It really is based on your application need and what it is you're trying to see. We've got one power supply, so it's just a 12-volt power supply that will plug into the back. That will power both the chassis and everything else within the system. And then we have the vents fitted on the back that will have the sample outlet, and then the vent from the channel that contains the carrier gas in there, and then a backflush vent as well if you have a backflush connected. All of those are quick fittings on the back. The carrier gas is just your normal swage lock 16-inch fitting on the back, and the sample is introduced on the front. And then we have various ports on the back in terms of communications, but that will be based on what you're actually trying to do with the platform, and it's more related possibly to the process system, which I'll delve into a little bit later on. In terms of column choice, there is a very wide range here of what we've got to offer to people. Now, typically, people are wanting to work to look at fixed gases, permanent gases is one of the really big applications of micro GC. So things like helium, hydrogen, nitrogen, oxygen, methane, CO. Emulsive is obviously very good for that. It comes in various lengths, so we can have 10 or 20 meter based on what it is we're actually trying to do or to separate. And then there's a variety of pre-columns that we can fit, say 1, 3, 5 meter onto there, again based on certain things that we're trying to get rid of, normally related to CO2. So if there's a large amount of CO2, we want a longer pre-column within there. But we've got options within all of these columns and channels to change the length of those analytical parts. So mainly CP, emulsives, poroplot, U and Q to allow us to do the low hydrocarbons and CO2 and H2S are very popular configurations. But all of these options here are to be discussed individually on a customer basis to see what it is they would need and what's going to be the most flexible way of actually doing it, whether we can get it in 1 channel, 2 channel, 3 channel, 4 channel, etc. A huge choice for that. So in terms of application fields, what this means really is that we see a lot of interest in natural gas and the energy markets for NGA, RGA type work, biogas, increasing work in fuel cells for the EV manufacturers. So if they're looking at hydrogen within there, or hydrogen impurities, it's a very fast and quick way of checking that the process may be operating. Environmentally, we have in this country a lot of need for the permanent gases and refrigerants, not as much for things like mine safety, but globally that is one of the big applications for Agilent within there. Reaction monitoring is a big one, certainly within academia. If you're looking at, you've got bioreactors, fermenters, anything where you're wanting to try and measure the gas very quickly so that if you need to, you can change your process, then the micro GC can offer a really, really valuable part of that for you. Now, as we do have main applications, as I mentioned, like NGA, biogas, RGA, we actually have solutions that are already set up, which are quite nice if that is the area you're working in. So they basically come as a single part number where the system is configured either in its normal version or an extended version based on how many compounds you want to analyze within these application fields. The systems will come factory tested out with an actual calibration gas. So when they come from the factory, they will be calibrated. You will have your methods loaded onto there, and you will have cal gas to use as checkouts for that. And then you can basically just set the system up immediately and you can start to run your processes. If you aren't buying dedicated analyzers, there's obviously a little bit of background work that needs to be done in terms of optimizing method parameters, finding the right calibration gases, which is fairly easy for us to do, but this does offer quite a nice solution where it's just ready-made, essentially straight out the box. You can get on and start analyzing your samples. So in terms of performance, when we look at repeatability, the micro GC offers excellent reproducibility, whether that is in the retention times or whether it's in peak areas. And this is really because we are only ever working with gases. We're working with small amounts of gas, and we are working with a very reproducible way of collecting that sample. So because we do it by time rather than volume, as I mentioned before, it allows us to basically be very, very clear with the injections and what the analytical system is going to receive within there. And because we work isothermally, we're not having to heat up, cool down, change rates. We are literally set at the same conditions all the time that allow us really to get this excellent sort of performance out of the system. So what we've got the option of doing is actually taking a lab version instrument, if you like, out into the field. So we have or see a lot of interest because it is so lightweight, taking this system out and being able to either do analysis around plant or to actually take it into the field itself and to do some measurements, whether that be out at other customer sites or whether it actually be out at different parts within your plant. Now, what we do here is to essentially change the chassis that the channels will be housed in. So there is an industry standard Pelican case that comes with. It's got trolley function, so it's got wheels, convenient handles. It allows you to lift things in and out easily, whether you're going in and out of the car or from site to site. And as people will know, if you've worked with Pelican cases, these are very, very rugged, watertight, crush-proof, dust-proof. The micro GCs have been drop tested as well. So there are a lot of instruments that will go out offshore. They often have to be taken off of helicopters, which aren't always the most sort of careful with these instruments. So they can withstand drop tests for going out to offshore platforms if needs to. And the case has automatic open and close detection on there, so it will actually shut off if it needs to. So to take a little bit more of a deep dive into it, it's not just a protective case. And I think that's one of the key parts of this. So obviously Pelican cases are used for transport, but this particular field case is designed so that you can run this anywhere. So it has built-in batteries. So you can have 2 batteries in there that allow up to 8 hours of battery time or of operation. And we also have the carrier gases built in to the system, which are refillable and quick connect. So you will have total operation from running this case. You don't need to connect it up to anything when you're out in the field. You don't have to take any carrier gases or cylinders around with you. You simply just connect your sample into the front, and then you can run the methods from there. And we do this by using our mobile software that can connect via Wi-Fi and a dongle through to either your laptop, to your iPad, to your iPhone, and then you can operate from there any of the methods being set up, and then you can analyze anything up to 8 hours from there. So it really does offer true mobility for you, and the ability to essentially just carry AGC around anywhere you want. So the other option that we have, other than the lab and the mobile instrument, is what we call the 990 Pro. Pro doesn't stand for professional, it stands for process. So this is designed to be what we class as an online or at-line process tool. So essentially continuous monitoring of a particular sample stream. The difference between the 990 Pro and between the 990 mobile and lab instrument is that essentially there is an onboard computer on this platform. Now, physically and visually, they look very, very similar, if not exactly the same. But the main board within this platform is able to have methods downloaded to it and stored on it within here. So when you set the instrument up, you'll connect up your laptop, download your methods, calibration files within there, and then essentially you can disconnect from that. What we do is to connect to DCS software, so whether this be Modbus, Profibus, whatever external data handling software that you've got, and essentially the micro GC becomes a slave to that, so it is controlled via this central system. So you can do peak integration, identifications, calibrations, you can run sequences, you can set up different streams within here. Basically completely autonomous without having an operator there. So they can be located in a plant, and once they're connected to the DCS, they can be operated from a central control room, and they will just run and basically do what they're told and spit numbers back to you. We have the option to load them into 19-inch racks. So again, industry standard racks that they can put into different enclosures. And we also have the ability, if needed, to build into an ATEX shell. So they can go into an ATEX explosion-proof enclosure and then be operated exactly the same. So what the system can do, as I say, is to speak basically, or to interact with the DCS system. So it does this via an Ethernet connection normally. You can have analog outputs if you want digital, probably a little bit easier. But basically, it can control lots of different things as part of the process, or however you want to set it up. So you can set up alarms for certain events. So if you had a process where you didn't want hydrogen to be above 10%, the system can analyze every 2 minutes, 10 minutes, however you choose to do that. As soon as it hits a certain event, it will trigger that alarm and it will send the signal to the DCS, and then the DCS then can control another part of that process to maybe shut part of the plant down, whatever it's needed to do. So it's a really, really quick and robust method, and it can handle very harsh environments if it needs to as well. What we can also do with the software, and not purely just related to the Pro, the lab instrument and the mobile can do this as well, is to basically have automatic calculations performed. So big studies in terms of calorific value, so energy metering companies will be looking at this to check the calorific value of the gas. So you can set the system up to automatically perform these calculations, and then it will give you the result of what you need to whatever standard that you're working to. This is the same for LPG and combustion calculations. We also have the option as well with one of the software packages to create bespoke calculations. So if there is something specific to your application or potentially a customer of yours that you'd want the analyzer to do, it is possible for us to work with you to create these. We have an option to have a touchscreen on the top, which some people like to have when they're operating the mobile and the process systems, because it's a quick overview of the sample condition. So it's not necessarily giving you peaks or heights or areas of peaks. It's going to tell you what your channels are at, whether they're operating at the correct temperatures, pressures within there. It'll show you the common method that you're using within that. If you've got calculations set up, it will show you those, but it wouldn't show individual peak concentrations if you had, say, 20 compounds of interest. It's really just a quick visual check so that you know what's going on, because generally it's not connected up to a laptop at this point. So the main thing that we normally have to configure is the sampling of the systems. Now, the micro GC itself can only take up to 1 bar of pressure. We need the sample gas to be below 110 degrees and we need it to be dry. So we have various options on here that can help us to get the sample into the best sort of condition for the analyzer. The most common one is to fit a Genie filter on here. So where you can see the line on the front, there's tubing going to, that's the sample inlet. We would have the Genie filter in between the sample inlet of the instrument and the sample line of whatever it is we're trying to analyze, whether that be from a continuous process or from elsewhere. So the Genie filter essentially has little membranes in there that will take out the particulate. So if there's a little bit of moisture or there's dust or anything in the line, this membrane will block that and ensure that there's nice clean gas being delivered to the micro GC. Another one is to reduce the pressure. So as I mentioned, we can't have it above 1 bar, and that is because of the nature of the system. So all these parts are micro machined. Things like the O-rings, the seals, the injector itself cannot handle high pressure. So we have to make sure that if you're coming down from 20, 10, 5 bar, that we can get it down to 1 bar effectively. So the pressure reducer is one way of doing that, where your sample line would come into one end of that, and essentially a needle valve that we can set the pressure down to typically 0.7 bar. And this can either then pass straight into the GC, or it can then pass into the Genie filter and to the GC as well. So this pressure reducer can drop it down from very high pressures if we need to. We also have the option for manual injection. So not everybody will want to work with a continuous stream of gas. Certainly if you were working in the field, you would want to be injecting a sample, and whether that is from a syringe, whether that's from something like a Tedlar bag, you can actually connect them onto the side bracket onto here. There is an option to switch between continuous and manual. So there's a little 3-way ball valve on the back of this bracket that allows you to switch between the two. The manual injectors, when they're fitted with those, have a pressure relief valve inside the GC. And that is just to stop if you were pushing in from a syringe, pushing too much and breaking some of the seals within there. So there's an overpressure relief valve that if it got to 1 bar, it would get rid of a portion of that sample from you. You do have to be quite careful in terms of volumes and how you do introduce when you're working with a manual injector, because with a continuous stream, it's easy for us to fill the sample loop. If you're working with very, very small amounts of gas, we may have to adjust some of the internal pump settings or the sampling time in there, but it's something that we work with customers on to do. We then also have a micro gasifier. Now this is really solely to do with LPG and LNG samples that are going to come in high pressure, wet, hot gases. So basically everything that we don't want to be putting in the micro GC. The micro gasifier will handle this for us, and it will deliver the sample dry, low pressure, low temperature to the GC. And then finally, we have stream selector options within here. So if you are someone that's working with a lot of reactors, or you're working from a lot of continuous sample streams, we've got the option here to add Vici valves on the side. So they come in a variety of configurations, whether that be flow through or dead end. Flow through is a better option really, because the samples can just come in and out, and then they can be selected by the software when we want to analyze them. You can have between 6 to 16 positions within these selection valves, and you can actually cascade up to 3 valves at once onto the system. So if you were working with 3 16 position valves, you can feed a lot of streams obviously into the analyzer, into here. The flow through, like I said, are best, and they can be dead ended if they need to. So they do give us the best option for introducing samples into there. And the stream selector can work with a Genie membrane and or pressure reducer in between the sample line as well. So it gives you a lot of autonomy. And then once it's all connected up, you can create sequences. So you can sample from different reactors at different times, and then you can interrupt these sequences as and when you want. And that is not just for process systems, that is for the lab instrument as well. You can't fit the stream selector to mobile systems. That is just a single sample inlet platform. All of these accessories are nicely fitted with brackets, whether if you choose the lab or the pro system. And these can be upgraded if we need to in the future. So in terms of summary of the system itself, the main benefits are we are cutting the analysis time down to seconds. So rather than 30, 40 minutes for analysis, we're down to 1 to 2 minutes. So 60 to 120 seconds for most of the methods that we would use. It is incredibly reproducible, incredibly reliable. And this is mainly due to the design of the system and the fact that we're working isothermally as well. Incredibly small footprint. Physically and environmentally, which is very important. So low carbon footprint, reducing the amount of carrier gas you're using, which can be a big benefit to people as well. It is an industry standard, so as anyone familiar with the Agilent products, it's a market leader in GC technology and something where we see very, very commonplace for a lot of the applications that were mentioned before. And really, it's future-proofing your platforms because it is so modular. So whether you start with a one channel and your needs change where you have to add additional channels, or you want to change the columns that are within those channels, it gives you a lot of flexibility to actually start with a particular configuration and then move as your needs move as well. So that brings us to the end of the presentation. We're going to have a Q&A session probably for 5 or 10 minutes within there. I will pass back to Annika to see whether we've got any of those, and then we can have a discussion to go through any of them. So thanks for listening, everyone.
Thank you very much, Duncan, for that very interesting presentation. We do have some questions. There is a Q&A tab at the bottom. If anyone does have any questions, feel free to ask away. So Duncan, one of the questions we did get across is what software options do you offer with the 990 Micro GC?
Okay, that's a good one. There are a variety, so it's really based on the instrument type and really what you're used to, I guess. So Agilent obviously provide their own, so there's an EasyCrom Open Lab option within there. So if people are used to using that for other instruments, that's quite a good place to start for them. We have options for the mobile and the process systems, which are a bit more pulled back, a bit more dedicated just for the Micro GC. So the Agilent Open Lab software is to cover various instruments, not just the Micro GC, whereas the Pro and the mobile platforms are stripped back a little bit. They're a bit more dedicated just for those particular application areas. And we've also got, we work with another VAR company that supply a dedicated one for the lab, so it's called Soprane. That has benefits in terms of if you're doing studies over time, it can create sort of trends analysis very easily for you. So it comes down to what the customer is used to or needs within there, but there is quite a lot of options available.
Okay, thank you. The other question we've got up here is, can we swap between different carrier gases, for example, helium, hydrogen, or argon? Which one do you recommend, and when would you say to use which one?
Yeah, sure. Yes, you can. The instruments have to be configured at point of sale, if you like, or manufacture for a particular carrier gas, but it's really just so that the system can be checked out and that the software knows what it's looking for. The software has to understand what carrier gas is connected, because that's how it operates. rates from the TCD point of view. If you started life with your instrument with helium on a MOLSIV, for example, and you needed to change it in the future to argon, you simply just disconnect it at the back, put the argon feed in, and then you tell the software what it is. So the software doesn't automatically know what it is, you've got to actually tell it. But you can change that as your needs change. And if you want to have a different carrier gas for each channel, that's possible as well for you.
Okay. And how easy it is to swap the channel on a 990 system? Because we have one of the older 490 models, so just be good to know what was
a lot easier if you've had a 490. I'll show you just quickly to hold up again, just to highlight how small and light. This is actually the micro GC here. Okay, so this is a 2-channel chassis. What we have is a channel here, and that would fit into the top or to the bottom if you had a 2-channel system. So on the micro GC itself, we can just take off the front panel. So on here, we just disconnect this. So it's one screw, we take that off, and there's a little sample bar on the front. We disconnect that, and we can basically just pull this out like a cartridge. Okay. So this particular one doesn't have the gas control module on, but it would just be basically a rectangle you fit in, and it's got the quick connect fittings in there. If you're wanting to change just the column, you would take your panel out, and then you've got access in here to the quick connect screws this side, take out your column, and then you can replace it with another one within there. So compared to the 490, which you couldn't do any of that with, it's incredibly easy. And also, if your needs change or you want to add ones in the future, you've got the option there to change modules, channels, or just columns.
Okay. Thank you. We still got time for a couple more questions. So, I mean, the other questions we've been asked is we're interested in the technology with a limited budget. If I was to purchase a basic system upfront, how easy and how flexible it is to upgrade or to add extra features moving forward?
Yeah, again, a lot easier than it used to be. If you were to, for instance, start with just a single channel system and a manual injector on the front, if you then decided that you needed an additional channel to analyze different gases that you were interested in from your research point of view, you can just swap one channel out or the column, or you can add the second channel into there so that you've still got the 2 capabilities. If you need to buy any of those accessories that I mentioned, so things like the Genie filter, pressure reducer, stream selectors, they are all available as standalone parts, so they can be upgraded relatively easy in the field. Again, normally it's just a case of fitting the brackets onto the side. So here, the screws on the side where the brackets will go into, and then you just configure in the software to tell it what's on there. Stream selectors connect with a USB, so they automatically identify what the stream selector is, whether it's flow through, dead end, how many positions of it, and then you're good to go from there. So it's very doable and very easy to do.
Okay. Our application involves several reactors. Can we have multiple gas streams going into one system?
That's where the stream selector would come into, really. So if you're someone, well, a lot of our customers at universities that will have fermenters or bioreactors, they will be collecting the gas coming off these feeds, and then they can take those feeds into the stream selector. It depends. Sometimes it can be a little bit tricky if you haven't got a lot of gas generated within there to do that. But if you've got different reactors that have got that are dotted around that do have pressure and flow, then it'll be absolutely fine. But we do that by the stream selector.
Okay, thank you. So that's all what we have in terms of time, in terms of the questions today. There are still a couple outstanding, which we will obviously come back to you on an individual basis. But I just wanted to take this opportunity, Duncan, thank you, and everyone for joining us today for this webinar. I will now stop recording the event with a view to end the webinar as well. Thank you, everyone, for your time.
everyone.